Good morning, students. We'll start now. So this is fifth module, uh, joint probability distribution and sampling theory. So in this class, we're going to see JPD, joint probability distribution. So what is this joint probability distribution means? So there is a definition here. If x and y are discrete random variables, normally in third module we did probability distribution where we have only one random variable. So one random variable is there, but here there are two random variables. So we're joining the variables. It means we're joining the x and y variables. So it named as joint probability distribution. See here, if x and y are two discrete random variables, we define the joint probability function of x and y, that is p of x is equal to x and y is equal to y, that is f of xy. So we have the condition. This is probability of xy, that is greater than or equal to 0. Always it should be greater than or equal to 0. We know probability function p of x, always it should be greater than 0, and summation of this is module 3, summation of p of xi should be equal to 1 unity. So same condition, since we have two variables, they name it as for two random variables, that is f of xy and summation x summation y for two terms, that is f of x comma y. So this is the condition. Next we have, suppose x is equal to value, some value, and y is equal to some value. So p of xy will be the probability, joint probability function. So denoted by j of ij. I will let you know how it came. And then this is a Cartesian form. Then f is also refers to joint probability density function. Okay. And set of values are given. Yes, right. So main thing is joint probability distribution. The set of values in a table, that is y values, x value, this is y value, this is x value, then the sum value, then the probability function values. So all these values, one is x, another is y, sum of x, this is sum of y, then j11 j12. It means if you multiply this part x1 y1, you should get j11. So x1 y2, you should get j12, or f of x1 or y of g of y2, you should get j12. So these are some conditions. So main thing is you should understand the concept properly. So when I explain the problems, you'll get to know how it came. Next thing is marginal probability distribution. See, marginal probability distribution is easy. So x value is there, x1 y1, and those function, it means probability of f of x1 is nothing but p of x1, there is probability of x1, f of x1 means probability of x1, probability of x1. Okay, that is called marginal distribution. If you mention only that part, see, f of x and x, while doing the problems you'll get to know same thing. This g of x1 y1 and this y1 y2 are the marginal probability distributions. So next, you should know what is independent random variable and dependent random variable. Students, if you multiply f of x1 into g of y1, you should get j11. Am I right? See, this is row and this is column. If you multiply f of x1 into g of y1, you should get j11. It is nothing but jij. If it is equal to that part, not only that one, f of x2 into j of y2, you should get j of 22. Am I right? So if it is equal to that part, so it is independent random variable. Those x and y are independent random variable. If it is not equal to that part, they are dependent variable. That's all. This is the main condition they will ask in the problems. Next, there are some formulas. So list of formulas in for expectation, that is e of x is mu x. It means how to find e of x means summation of xi into f of xi. Okay, that is the formula. Then e of y means yj into g of yj. If it is three elements, means x1 f of x1 plus x2 f of x2 plus x3 f of x3, like that we have to add. So that is e of x. Then e of y means same thing, x1 g of y1 plus y1 g of y2 plus y3 g of y3, up to where it ended, you have to take that part. So this is e of y. Then e of xy, same thing, x into y into jij. So this we need a probability distribution table to find e of xy. And then variance of x, e of x square minus mu x square. Mu x means e of x. Same thing. So for before doing going to the problems, you have to practice these formulas and all, very very important to solve the problems. And one thing that dependent and independent also, and how to find jpd and marginal distribution table, that's all. This concept will get finished. You have to understand jpd, then that part, marginal distribution, then independent and dependent, these formulas. This help you to solve all kind of problems in joint probability distribution. Next, standard deviation of x, that is sigma x is equal to root of vx. Root of vx means we know vx is nothing but e of x square minus mu x square. Next, y is nothing but v of y. Next, covariance means e of x y minus mu x into mu y. Okay. Correlation means covariance, we need covariance of x divided by sigma x sigma y, that is standard deviation x standard deviation y. Now when they are independent random variable, it means x and y are independent variable, we have some conditions which should be satisfied only when they are independent variable. When they are independent variable, e of xy should be equal to e of x into e of y. Then covariance of so covariance of x comma y should be equal to 0, and correlation of xy should be equal to 0. So these are the some conditions only when x and y are independent variable. So if they ask you to show that it is a independent variable, you have to show that it is not equal to 0 and satisfy the condition in independent variable, means you have to use any one of these condition. And if they ask particularly do it on covariance, means you have to do it on covariance. Next, first problem we'll see. Very easy concept. First problem is very very important. It is basic for all kind of problems. So now we see the joint distribution of two variables x and y is this. Okay, y is this and x is this. Now compute the following. So how to find the um, e of x and e of y? So this is joint probability distribution, it is jpd. Correct, it is jpd. X value is there and probability, and when x is equal to 1, y is equal to minus 4, your answer is 1 by 8. That is joint probability distribution. Joint probability distribution of 1 and minus 4 is 1 by 8. Joint probability distribution of 1 and 2 is 1 by 4. Joint probability distribution of 1 and 7 is 1 by 8. 5 and minus 4 is 1 by 4. 5 and 2 is 1 by 8. 5 and 7 is 1 by 3. It is not probability function, but it is joint probability function or joint probability distribution, we can say. Now how to find this e of x and e of y? See students, before finding e of x, we need f of x and g of yj. Correct, f of xi, g of yj. It is j11 j2, it is not f of x1 g of y1. So what we'll do, first we'll find out f of x1 and f of x2, or g of x1, g of y1, g of y2, g of y3. So what we'll do, marginal distribution of x is 1. Correct. 1 is, first we'll write down 1 and 5. Okay, 1 and 5. How we got 1, 1 by 2 here? For 1 means, see students, this is 1. So for 1, jpd is these 3. It means 1 by 8 plus 1 by 4 plus 1 by 8. Denominator here 4 is there, we'll make it as 8 into 2 by 2, so that you will get 1 by 8 plus 2 by 8 plus 1 by 8. So what we'll get, 1 plus 2 plus 1 is 4 by 8. 4 ones are 4, 4 twos are 8. So your answer is 1 by 2. It means if you add these three terms, you will get 1 by 2. So same thing for 5. What we have to add? We have to add 1 by 4 plus 1 by 8 plus 1 by 8, so that you will get again 1 by 2. Correct? So this is about marginal distribution of x. Next, marginal distribution of y. So first thing for 4, 1 by 8 plus 1 by 4, that is 3 by 8. Next, 1 by 4 plus 1 by 8, that is 3 by 8. Next, 1 by 8 plus 1 by 8, that is 2 by 8. 2 by 8 means 1 by 4. So like this we got marginal distribution of x and y. Now main thing is e of x and e of y. So e of x means we know the formula summation xi f of xi. So x1 f of x1, x2 f of x2. Same thing for e of y, that is summation yj g of yj, and y1 g of y1, y2 g of y2, y3 g of y3. So x1 we know f of x1 1 by 2, correct? x2 is 5, f of x2 is 1 by 2. So if you add, that is 1 into 1 by 2 is 1 by 2, plus 5 into 1 by 2 is 5 by 2. So it is 1 by 2 plus 5 by 2 is 6 by 2, where 6 by 2 is 3, where 6 by 2 is 3. So that is e of x. Similarly, if you add for e of y, you will get the answer as 1. You get the answer as 1. So you use the calci or do simplification like that itself, you'll get. Next, e of xy, that is second one. E of xy, how to find xi yj j of ij with summation? So how many terms are there? See students, x1 y1 j11, correct? Next, yes, we got here. So next thing, x1 y2 j12. Yes, same thing. x1 y3 j13. See here, same thing. x2 y1 j21. See, always this way this thing should be, I will mention and show. See, this is y1 y2 y3. Next, this is x1 x2, and this inside terms are, see, this one is j11 j11 j12, and third one is j13. Next, j21 j22 j23. So if you do at once, you will get to know how it happened. Next thing is, I will tell the numbers, it will be easy. 5 into minus 5 into minus 4 into 1 by 4. Yes, here you got. Next, 5 into 2 into 1 by 8. Next, 5 into 7 into 1 by 8. So formula is important. There is marks for formula. So don't forget to write the formula. Yes, if we add all the terms, you'll get the answer as 3 by 2. Simplification part it is. Next, sigma x and sigma y, that is standard deviation x and standard deviation y. So how to find standard deviation x, standard deviation y? It is about the variance. If you find the variance, after finding variance, if you do the square root, that is standard deviation of x. So the formula is e of x square minus mu x square. Okay, we know mu x. Mu x is nothing but e of x only. That is 3. Okay, 3 square. But we don't know e of x square. So e of x square means same thing. Summation xi square into f of xi. That is x1 square f of x1, x2 square f of x2. You will get 13 as the answer. By using marginal distribution table, you will get it. So same thing after substitution, you get sigma x. Same thing for variance of y, and that is sigma y. Now we need covariance of xy. Covariance of xy is e of xy minus mu x mu y. Okay, we find it mu x mu y, that is the first thing. Next, e of xy also we find it. So after substituting those values, you'll get covariance. Next we did sigma x sigma y, then covariance of xy, so that we can easily find correlation of xy. So understand the method to solve the problem. Simplification part is easy. In this, very important thing is formulas. Just remember the formulas and solve it and move. Next, second one is the joint probability distribution. So they have given JPD. Okay, they have given JPD and determine the marginal distribution. Okay, you know how to find marginal distribution. We have to add for x we have to add 1.1 plus zero point 0.2 plus 0 plus zero point 0.3, that is zero point 0.6. Next zero point 0.2 plus zero point 0.1 plus zero point 0.1 plus 0, you'll get zero point 0.4. So same thing for minus 2, zero point 0.1 plus zero point 0.3, zero point 2 you'll get zero point 0.3. Zero point 0.2 plus zero point 0.1 you'll get zero point 0.3. 0 plus zero point 0.1, 0.1. 0.3 plus 0, zero point 0.3. Yes, this is marginal distribution. That is over. Now also compute E of x and E of y. So you know how to find E of x and E of y, E of xy. Same thing, sigma x and sigma y covariance and this correlation as you did in problem 1. Now in this main thing is verify x and y are independent variable. So dear students, will see the condition for dependent variable. So what is the condition of dependent variable means? See, f of xi g of yj should not equal to jij since. Then it is dependent variable. If it is equal, it is independent random variable. Okay, we will see that. So students, with the help of JPD, we're going to solve it. With the help of JPD, we're going to solve. So we need this f of x and g of yj also. You take any number. For example, we took f of x1. F of x1 is 0 0.6, correct? F of x1. Next, g of y1, it is 0 0.3. So what you will get? 0 0.18. 6 3 is 18, so 0 0.18. Now this is f of x1 and this is g of y1, so it is nothing but j11. These numbers we have to concentrate. X1 y1 means j11, x2 y2 means j22, x1 y2 is 2 1, sorry 1 2, so like that you'll get. So j11 means this one, you know very well. J11 is what here? 0 0.1 and here 0.18. They are not equaled. When it is not equaled, what it means? They are dependent random variable, so hence it is verified. You see, I have solved here. So same thing, 0.18 and you get 0.1, so it is not equal to, so it is dependent where one condition is enough. If you want, you can solve for second condition also, x2 y3 also. You can take randomly any number which is available there, so that again it you'll get not equal to only, so you will get dependent variable. Now what is the probability when x plus y is greater than 0? First write down the numbers those who having greater than 0. That is x and y, if I add you should get more than 0. First we'll write down that part. So what are the numbers which is greater than 0? So dear students, what we have 1, okay, we have 1 minus 1. We have 1 minus 1, so 1 minus 2 is minus 2, we will not get. 1 minus 1, 0, that one also will not get. 1 4, correct? 1 4, so that you will get greater than 0 5 now. Next 1 5, 1 5 is nothing but 6. If you add you will get 6, 6 means greater than 0. Next 2 minus 2 you will get 0. 2 minus 1, correct? 2 minus 1 means 1 will get greater than 0. Next 2 plus 4, 2 4 means 6, it is greater than 0. Next 2 and 5. So these are the x and y terms which is greater than 0. So what is the JPD for this? So what is JPD when 1 and 4 we have 0? You have to add plus. When 1 and 5, what happened? 1 and 5, we have 0.3, we have to add this. Next, 2 and minus 1, 2 and minus 1 means, see dear students, here it is, 2 and minus 1 means 0.1. Yes, okay, 0 point plus 0.1. Next, yes, plus 0.1. Next, 2 and 4, 2 and 4 means, 2 and 4 means again 0.1, 0.1. Next, 2 and 5 means 0. Yes, I will show you, you get an idea. So dear students, here it is, 1 yes, 1 4, same thing here, 1 5 is here, 2 minus 1 is here, 2 4 is here, 2 5 is here. Next, I told you 0, 0 0.3, 0.1, again 0.1, and then 0. If you add all those terms, you will get 0.5 as the answer. I hope you understood very well. So just solve it, you'll get an idea. Next problem. So next problem is, in previous two problems we seen probability distribution table and we have to find marginal distribution, but here it is different. They have given marginal distribution. So suppose x and y are independent random variable with following respective distribution, find JPD. Yes, very good. And verify. Okay, we'll see that verify afterwards. First we'll concentrate on JPD. Dear students, first write down x values, that is 1 2, horizontally write down x is equal to 1, y is equal to 2. Next, vertically write down x values and horizontally write down y values, that is minus 2, 5 and 8 here. Three values and three values. Now, write down this f of x and g of y. So this is sum, 0 0.7, 0 0.3, and here it is g of y. So for that values you have to write, for x is equal to 1 and f of x1 is 0 0.7. For x is equal to 2, f of x2 is 0 0.3. For y is equal to minus 2, g of y2 y1 is 0 0.3. So y2 is equal to 5, 0 0.5, and 8, 0 0.2. So the thing is here in red pen they wrote no 1. So this one is important. 0 0.7 plus 0 0.3 you'll get 1. Next, 0 0.3 plus 0 0.5 plus 0 0.2 is 1. So dear students, how to get this J11 J2, that is called joint probability. J11 J12 J13 J21 J22 J23. So how to find this part? Just multiply, that's all. 0 0.7 into 0 0.3, 0 0.21, 0 0.7 into 0 0.5, it is 0 0.35. Next, 0 0.7 into 0 0.2, you will get 0.14. So same thing, 0.3 into 0.3, 0.09. Next, 0.3 into 0.5, it is 0.15. Next, 0.3 into 0.2, you will get 0.06. So this is joint probability distribution. Next thing is covariance. It should be equal to 0 since, okay. So covariance of xy formula is E of xy minus mu x mu y. We have marginal distribution and JPD also. So E of xy we don't know. First we have to find E of x. E of x means x1 f of x1 plus x2 f of x2. Only two values are there. Okay, just add it, you will get mu E of x. Then E of y means same thing. Three terms are there. Next, xy means we know already. So substitute all these things in covariance. Yes, you will get 0. Hence it is verified. Main thing is how to find this JPT. That is very very important on this third problem. Next, next thing is very very important. So they have not given the table. Instead of that, they have given the values. So x take values 257. Okay, 257. And probability is they itself given respectively 1 by 2, 1 by 4, 1 by 4. So y takes values 345, and those values are 1 by 3, 1 by 3, 1 by 3. Now, first thing is find the JPD. So dear students, we know same thing. We have to write x values, y values, then f of x, the three values, g of y, three values. Then this condition, this you know, if you add 1 by 2 plus 1 by 4 plus 1 by 5, you should get 1, and this thing also you should get 1. And 1 by 2 means 1 by 2 into 1 by 3 means 1 by 6. 1 by 2 into 1 by 3, 1 by 6. 1 by 2 into 1 by 3, 1 by 6. So same thing. Yes, tell me. Hello. Hmm. Yes, you have to multiply. That is condition. Yes, yes, that is condition. Definitely you will get 1. See, if you add these probability function values, you will get 1. That is for sure. Okay. So then that multiplication you will get this inside J11, J12, J13, J21, 22, then 3132, 33. Have understood now? Okay, okay. Same, similar to this problem, previous problem. Third one we did no. So same procedure only we are going to follow here also. So this is about JPD. Next, second one is show that the covariance. So same thing, covariance we did here also. So if you solve for covariance, you will get 0. That is also possible. Main thing is third one. Find the probability distribution of z is equal to x plus y. So first we have to write what and all you will get for x plus y. So we'll see x plus y, and here 3, 2. Am I right? 3 and 2. If you add 3 and 2, you will get 5. I will write and show. 3 plus 2, 5. 3 plus 2 is 5. Next, 4 plus 5 is 6. That they itself given no x plus y. So 4 plus, sorry. Mm, First we'll do for x1, y1. 3 plus 2 is 5. Next, 2 plus 4 is 6. Next, 2 plus 5 means 7. That is over. Next, 5 plus 3 means, for each and every possible values we have to consider it. Next, 5 and 3 is 8. Next, 5 and 4 means 9. Next, 5 and 5 means 10. So next, 7 and 3 means 10. So 10 is repeated twice. Once is enough to write in the probability distribution. Next, 7 and 4 means 11. Next, 7 and 5 means 12. So dear students, this is Z. So now we have to find for this probability distribution. When x is equal to, when x plus y is 5, it means x is equal to 2 and y is equal to 3. What is your answer? 1 by 6, students. So that you have to mention. So for 5 it is 1 by 6. Next, when x is 2, y is 4, you will get 1 by 6 again. For 7 also you will get 1 by 6. So I will show you how we got that point. Yes. So this we know covariance how to find. Main thing is this x plus I. See zi they mentioned like this 5, 6, 7, 8. Yes, 5, 6, 7, 8, 9, 10. 10 repeated twice. So at once is enough to write in the table. Next 11 and 12. So they wrote here. Next, how to find this corresponding probability? See for 5 means I showed you when x is 2, y is equal to 3, you will get 5. So that the joint probability value is 1 by 6. So for 6 if you add, that answer will be 1 by 6. For 7 it is 1 by 6. So I will show you for 8. So 8 means what? X plus y should be 8. So where x and y is here 8 here? Yes, yes, 5 plus 3 should be 8. So our answer should be 1 by 12. Our answer should be 1 by 12. So yes students, for 8 our answer is 1 by 12. Yes, 1 by 12. Yeah, 1 by 12. So same thing for 9, 10, 11, 12. So this is about z is equal to x plus y. So understood now? Yes. Next thing is, yeah, yeah. Next thing is the joint probability distribution of two discrete random variables x and y is given by f of xy is equal to k of 2x plus y, where x and y are integers. Okay, where x lies between 0 to 2. 0 to 2 means 0 1 2. Y is 0 to 3 means 0 1 2 3. So x and values are given, and when x is equal to 0, y is equal to 0, what happened for f of xy? That is k into 0 plus 0, you'll get 0. Next, so main thing is to find k. To find k, we need JPD. So we are writing JPD, joint probability distribution. With the help of JPD, we're going to find k. Next, when x is 0, y is equal to 1, what happened? 0 k of 2 into 0 plus 1. So you'll get k itself. Next, when x is 0, y is 2, you'll get 2k. When x is 0, y is 3, you'll get 3k. So same thing, when x is 1, y is 0, you will get k into 2 into 1, so it is 2k. So like that, just substitute the values of x and y so that you will get joint probability. Now main thing is how you got this 6k, 14k, 22k. Just sum it is. See, here itself we mentioned sum. So if you add this part, it means 0 plus k plus 2k plus 3k is 6k. Next, same thing, 2k plus 3k plus 4k plus 5k means 14k. So same thing, if you add this row, you'll get 22k. And if you add this 6k plus 14k plus 22k, you'll get 42k. So same thing, or column wise we have to add, you'll get 6k, 9k, 2k plus 4k plus 6k, 12k, 3 plus 5 plus 7, 15k. So same thing, 6 plus 9 plus 12 plus 15 is 42k. So I told you here it should be 1 in joint probability distribution. In many problems we saw that one. Now to find k, we have 42k is equal to 1. 42k is equal to, it should be 1. It should be equal to 1. So what is k? 1 by 42. That's all. Next, so what we got? We got JPD, dear students. So with the help of JPD, we have to find marginal distribution seams. Second one, find the marginal distribution of x and y. So how to find marginal distribution of x and y? Marginal distribution of x means this 0, 1, 2, that is see here x2. So this is 6k, 14k, 22k. So k is nothing but 1 by 42. So 6 by 42, 14 by 42, 22 by 42. Say same thing for y also, 6 by 42, 9 by 42, 12 by 42, 15 by 42. So this is marginal distribution, that is finished. Next, yes. Yes, okay. So once you understand the problem, two problems you understand properly, it is easy to solve all the problems, because all the problems, same method we're going to repeat again and again. So next thing is show that the random variable x and y are dependent. This is the first problem, second problem we did. So same thing, f of x1, g of y2 should be equal to j12 means independent, not equal to j12 means dependent. So it is similar to second problem. So if you understand the second problem, you'll get to know how we got. Next, so main thing, this problem is very very important. So there is a fair coin seems, tossed thrice, okay, number of trials is 3, and random variables x and y are defined as follows: x is equal to 0 or 1. So dear students, x value should be 0 or 1 seems. So there are 50-50 chances, since it is possible probability chapter. When x is equal to 0 or 1 means there are 50-50 chances of getting 0 and 1. So according to head or tail occurs the first loss occurs on the first loss. So loss is nothing but 0. Dear students, loss is nothing but 0. And y means number of heads. Y means number of heads. So x means what? Number of tails. Number of tails. Now determine the distribution of x and y. Distribution or marginal distribution, both are same. So now, okay, we'll see this problem in next class. It is easy only, just solve it before I'm doing this problem. Okay, in next class we're going to continue. Yeah. Okay, thank you. Thank you. Okay, thank you. Thank you.